All right, good afternoon, everybody. So welcome to the Dash talk. I think the sign on the outside says that this talk is called the 3-year journey, but that's just because we didn't want to spoil our announcements today early. So what I'm actually going to spend time talking about is like how we've evolved this Rift system UX and Dash specifically. First, a little bit about me. So my background is in the games industry, but I've been at Oculus for about 3 years now. This is some of the things that I've worked on here. It's a bunch of really cool projects that I got to build with a bunch of really cool people. I'm still very much the same VR true believer that I was the first day that I showed up at work. So here's what we're going to go through today. Again, just sort of like covering the history, what we're doing with Dash, and then specifically I want to spend some time talking about development considerations for you as a developer and how Dash will impact you. So first, let's talk about the history. So our original system user interface for the Rift that many of you will remember is this screen. The early versions of the SDK were very bare bones that leveraged a lot of the existing PC desktop development tools that you're already using. And we had this little window here that would let you set the important settings on your device. I actually think this was an extremely good way to get VR development bootstrapped. Like the thing that actually got me into VR was realizing that I could hack the engine at my previous company to render in stereo. And then at the time, these development kits just showed up as extra monitors on your PC. And so like you would take that stereo window and then you would basically just drag it onto your face and you'd be good to go. But obviously there's some friction there in terms of the end user experience for like a retail product. But even then I want to call out, so we had this button in the lower left here that says show demo scene, which would take you to this space, which I also remember very fondly. And the reason that this existed was because we knew even then that it was very important to be able to modify some of your settings within VR. Like certain things were actually only really evaluatable when you were in the experience and seeing how the changes you were making were reflected in VR itself. And so, like, you know, this became a stable mainstay of many of us who were doing VR development, trying to figure out, wait, did I break the thing, or is my headset set up wrong, or whatever? I remember being fascinated when the DK2 came out because I could actually look at that stack of cards right there and like watch them parallax as I moved my head back and forth. It was really magical. We've come a long way. But we actually felt this pain of this like friction of coming in and out of VR even more intensely when we started working seriously on Gear VR, because it was one thing to like lift your headset up off of your face and like peek at what's going on your monitor and put it back down. It's an entirely different thing to take the device powering the experience, like and undock it from your face and mess with a 2D app and then stick it back and that kind of thing. And so that's when Home was born. So the idea behind Home, right, is that we just wanted to have a fully in VR system UI that made it possible to do all of the things that you wanted to do while you were inside of VR. And we wanted to bring this to Rift as well. So this is like an early concept piece that we had internally, was we were iterating on what the Rift version of Home would look like. You can see some initial exploration that goes beyond launching content that includes things like your device settings, and what your friends are up to, all that kind of stuff. But the important actual experiment in here was playing with like using physical materials and situating this in a physical space. We sort of discovered as we were building these things out that it was really nice to have a space that you could go back to that was familiar and calm and would basically let you acclimate as you were context switching between realities. And so we actually brought some of this thinking back to Gear VR as well, even before we shipped Rift. So the version of Gear VR Home that you would have seen prior to Rift launch would have been this one, which was this nice modern environment with a nice blue sky in the distance. It was one of the first examples of like actually us trying to turn Home into a home. And this is what we shipped for the Rift. So we brought a little bit more of the Oculus house style into the environment, and we've actually been on this environment for a long time. This is what you see when you put the headset on today. And this is actually, we brought this to Gear as well, and under the hood, this is actually a cross-platform implementation of Home that ran in both places. And it was designed on Gear to respond to the touchpad, and then the gamepad accessory if you had it, and then on Rift to use the remote or the gamepad, which we shipped initially. But of course, we launched an important new piece of hardware a little bit later called Touch, and we needed to bring touch support into the Home experience. So we did that by integrating the Avatar SDK, but we didn't change any of the major design affordances for the actual like interacting with the system UI. We just made it so that when you pointed with your finger, you got a little laser pointer, and you could still execute the same sort of like point at something and then tap on it in order to do the thing. So that's kind of where we are today. I want to talk about where we're going. But first, I want to talk about some of the like specific things that we'd like to address and improve in the experience. So first, I'm going to talk about this other space that exists hidden inside of Home called Universal Menu. So when you push the Oculus button on your touch controller, we bring you to the space that we call the void. It gives you basic access to the options that you need for survivability in VR, right? Like things like recentering your view and adjusting your volume. And the problem with universal menu is basically everything that you don't have access to, which is sort of everything else on the platform, right? And just as one illustrative example, like think about like app switching, right? Like you're in a VR experience and you want to go to a different one. So this is what it looks like in the current version. So you're in the app, you push the Oculus button, and context switch you into the void. You have to go find the exit button, close it down, it'll fade out, and context switch you into home, where you can then go browse to the library, find the other piece of content that you want to launch, and then context switch again into the void, and then load it, right? So it's like this very kind of like monolithic process that introduces a lot of friction when it comes to like, you know, this sort of like VR computing platform concept. By the way, old friend, chocolate, highly recommended. They're like a dopamine rush. It's a great way to start your VR development day. So the other thing that we want to focus on is like the stuff that you still have to take your headset off for, right? Like we've pulled a lot of that stuff into the core system UI. There's just a lot that's left, right? And it's sort of stuff that's not part of our core platform, right? Like, you know, it might be that there's some setting that only exists in the desktop app that you need to modify, or it might just be something as simple as like you wanted to go check something on the internet, or somebody sent you a message and you need to take your headset off to go look at it and respond to it. So those are the kind of problems that we want to solve. How do we want to get there? Well, so these are our core two design principles that we've used in reimagining the Rift system UI. Talk about each of them in turn. So the first is we want to take full advantage of touch, right? We're actually really proud of the touch controllers. Like they have this really great ergonomic design. The tracking is really high quality. You really do get this feeling that you have your hands in VR and that the controllers just fade away over time. It's a really powerful tool for designing interfaces. And the important thing that it does is it allows us to bring that UI into your personal space, right? Like it's not confined to some fixed distance so that you can gaze far enough to tap on it, right? Like you can bring stuff right near you, you can move things around. You can really just take the full advantage of the spatial affordances that you get from having your hands in VR. And the other thing that's important to us is this idea of like thinking of VR as a computing platform, right? Like the Wikipedia definition, or at least when I copied it into this presentation, was a computing platform is the environment in which a piece of software is executed. And the thing is like as a computing platform, VR has really unique opportunities. So the first is that execution environment is literal, right? Like we can deal with real spatial considerations. We can compose that space however we want to achieve things that allow you to like manipulate space and time exactly as you want to. And then the other thing too is like, you know, the real world constraints don't matter, right? Like physics is what we decide it to be inside of VR. So we get all the strengths and benefits of the way that we actually in the real world get to use our hands, and then none of the restrictions that they impose. So how does that relate to Dash? Well, we've been working on Dash for a while. It looks like this. We showed it off in the keynote this morning. It's very pretty. It has a very nice, elegant design. It has this combination on the belt of like a scrollable tray of all of your utilities and applications. It's this utility belt that comes up right in front of you that you can access from anywhere. It's designed from the ground up for touch. You can just reach out and touch it. We've put a lot of effort into balancing sort of ergonomics, responsiveness, utility. We think we've landed in a really nice place where it's easy and intuitive to use while still delivering on some of that like core joy of being able to use your hands in VR the way that you would in the real world. Let's see. And then, like we mentioned earlier, that actually coalesces everything that we have across the platform experience. So all the functionality of home, all the functionality of universal menu, it's right there. It's available at the press of a finger. And the best part is that it runs as an overlay on top of the VR experience that you're inside. You can access it from anywhere. You know, we no longer have to take you to a totally different space for you to be able to interact with the interface with your platform, which just dramatically reduces the overall friction of the experience of trying to do something with your VR system UI. So if we go back to that example, in the Dash development build, you pull up your Dash, you hit the launcher, you launch the application, and you're there. It's much faster, simpler, and quicker. The other cool feature that we're introducing is Oculus Desktop, and this is coming back to that idea of giving you access to all the things that you used to have to take your headset off for. And it's more than just a mirror of your physical monitor, right? Like each of these individual applications can be given its own virtual monitor, and then you can arrange them in your VR space however you want to without the constraints that you would in terms of dollars or physical limitations in terms of assembling your perfect workstation. And it opens up all of these unique use cases, especially when you can consider that you can pin these over top of the experiences that you're inside of. So if you're using Medium, actually a lot of VR like sculpting applications have the ability to like pull in a JPEG and bring it in as reference inside the space. Now you can just get that from anywhere, right? Like just go to something on the internet, pin it over top, go back to the art that you were working on the same way that you would in a multi-monitor setup if you're a professional artist. It's a really potent kind of combination of features. But you don't just have to be productive. Obviously, media is a super cool use case as well, right? Like being able to control the music that you're listening to, or like watching a video while you're relaxing in VR. And then communication. This one's really important, and I think for us, from a practical standpoint, very helpful as we're doing VR development and getting pinged on Messenger all the time and needing to respond to things. Having quick access to your communication tools, no matter where you are, is super valuable. But the use case that by far is nearest and dearest to my heart is development. So here's some footage inside a development build. There's a lot going on. They slowed down this video because I'm pretty squirrely. This is me in Unity playing a VR scene, then pulling up the 2D Unity UI in Dash, modifying values live, and seeing them reflected in the space that I'm inside of before. This is a super powerful set of tools. It's transformative for our development workflows in a lot of different ways too. Like there's actually really mundane use cases that I find personally valuable. Like when I'm in a build, my old process for sending like review notes to people would be that I would take my headset off, pull open my physical notebook, scribble something down, put my headset back on, and then not remember what I was doing and have to kind of figure out what's going on again before I can get my next piece of comment. Now I literally just pin Notepad over the experience and take notes as I go. It's really great for us PM types. So anyway, that's Dash. There's a ton of really cool use cases. We'd spend all day getting into all of them, but it's a really powerful tool, and we're excited to get it to you soon. So let's talk about what it means for developers. So first, in order to make Dash work, to come up as an overlay, we're making changes to what we call the lifecycle. So right now, your application is in one of two conceptual states. The first is that you're active, right? You're receiving inputs, you're rendering, the person's live in your experience. The alternative is that you're suspended, right? It's either because another VR application has focus, or they're in universal menu right now. We're introducing this new intermediate state when Dash is up. The idea here is that your app would continue to render, but no longer consume input, so that people could actually interface with their system UI. And so there are a couple of things that you need to do for your application in that case. So the most important thing actually is just like not rendering your hands or controllers or processing input while Dash is up. Because you don't want to double up on the hands. You don't want people to be trying to interact with their system UI and accidentally doing stuff inside of your experience. But there's more that you can do depending on the type of app that you are when the system UI is up. And it's kind of contextual. So like if you're a single player game, it's fast action. You don't want them to miss anything while they've got the system menu up. You can keep rendering, but pause the action. Or if you're in a multiplayer situation, it might be useful to broadcast the away status for your participants so that people can know that that person's in the system UI and may not be able to interact with you right now. Another thing too is like if you just have a bunch of near field elements that are common in your scene, when the system UI is up, if you want to hide those so that they are not in people's way as they're trying to interface with something, that can be helpful as well. For the programmers in the room, if you're working on a native engine, here are the keywords to search for. The basic idea is that when you initialize, you tell us that you're aware of these new focus states, and then you'll start receiving these two new status events. One is like, hey, whether or not you have input focus. If you don't have input focus, don't process input, don't render hands. The other is if this overlay is present. Right now, these actually change at the same time. It basically just corresponds to when Dash is up. But we suggest that everybody implement them independently, just as a form of future-proofing as the system becomes more sophisticated over time. If you're a Unity or Unreal developer, we've actually already shipped these lifecycle features. So if you're on a version of our Oculus utilities past 1.18, you can already implement this today. This supports Unity from 5.4.3 patch 4 or Unreal. It's in the 4.17 Oculus branch. It's in the 4.18 Epic branch. So you might be wondering, like, well, so what do you do if we like don't support this, or we're a legacy application or something like that? Well, the basic answer is that we fall back to the void. It functions basically the same way that it does today, right? Like you hit the Oculus button, you go to the void, we bring up your system UI there. They do get all of the benefit of Dash. So like, the improvements that we're making to the overall system interface, the ability to interact with your PC. You can even pin a window and then go back to your experience. But you can't bring up Dash inside of the experience unless you implement the new lifecycle. There's another thing that you can do that will make the integration even better too, which is that we now allow you to submit depth buffers for your scene. And I'll talk about why we do that. So in most cases, right, if you just have a normal scene, VR apps tend to not put a ton of stuff really close to the player all the time. And so Dash, we can just render it directly as an overlay on top of it, and it's fine. But if you're really close to an object, then you would wind up in this situation where it's like you're bringing up the UI. The UI is trying to come up further away than the stuff that's being rendered inside of your scene. And so we can just render it right on top of that, but this creates this sort of interesting optical effect where it kind of punches through the scene, masking out the stuff that's in front of it as if it was cutting away into it. And then what you can wind up with is this sort of like steep jump in sort of depth perception on the boundaries of these lines. But what most applications do is they already produce a depth buffer that encodes information about what's near and far inside of the scene. And so you can actually submit that to us, and then in our compositor, when we're rendering Dash, we can do this new X-ray effect, where we ghost out the stuff that is occluded by the geometry, or by the system UI, and let you see through to the interface. And the thing that's actually really cool about this, it's kind of subtle in this screenshot, but when you're actually in VR, the effect of this is that you actually preserve all of the stereo and detail of the geometry in the scene that's close to the user. It just becomes transparent, and you can see through it to the system UI. So it's a totally comfortable, really great way to sort of cleanly insert these system UI elements into your experience. Again, for the programmers in the room, you submit your depth buffers basically exactly like you do your eye buffers today. Like you already submit those textures to us so that we can composite them. You send depth basically the same way. You can search for these keywords in the SDK to learn more. If you're a Unity or Unreal developer, for Unreal, we've already shipped this feature. You can use it in 4.17 in the Oculus branch, 4.18 in the Epic branch. We're working with Unity on getting this integrated as well. It's definitely going to be in 2018.1 as a public release. We're working on preview builds coming soon. If you're interested in getting it for an earlier version of Unity, I'd recommend that you reach out to our developer relations teams. They might be able to help you out and get you something sooner. All right, a few more considerations. So you might be wondering about frame rate impact. Dash has very little overhead when it's inactive. We have some deep GPU resources allocated so that we can bring it up quickly when you push the Oculus button, but no frame rate impact. When it is active, we're trying to be extremely lean and keeping ourselves to a 2 millisecond buffer. So if your application is sort of like right at the line of running at full frame rate, that might cause it to tip into the area where we cover up frames with asynchronous space warp to make sure that it's a comfortable experience. If we do find that it is actually degrading the experience too much and is causing frames to be dropped, then we'll actually fall back to the void so that people will continue to have a comfortable experience. Another thing, not everything shows up in depth buffers. A common example is like particles and translucent objects. The thing that winds up happening if an object in the scene is not captured by the depth buffer is that it still has that punch-out effect where it gets masked out. We find in practice through testing, this typically isn't a big deal. Like they're already a little bit ephemeral, they're already partially transparent. It's usually OK for those elements in the scene to disappear, and it's better. It's more important to make sure that the static geometry is like really cleanly represented in terms of any overlay with the UI. But if you do actually have a problematic case, like a particle system that's like constantly in the near field that's important to your experience, one thing that you can do is look for when the overlay is present and just like write application-specific logic to hide those elements. The other thing is submission requirements. So the important thing here is that if your application now reports that it's focus aware, we're just asking you that you hide your hands and controllers when you're out of focus. Basically, if you say you support the flags at initialization time, that you actually follow those and implement them in the way where it will interface with Dash correctly. The focus aware bit is on by default in those engine integrations that I mentioned earlier that ship this feature, so be aware of that. The depth submission stuff helps, but it's optional. You don't have to do it. All right, cool. That's a little bit of a whirlwind tour, but we have a little bit more time, so why don't we take some questions?